Okay, good morning, good afternoon, good day. So depending on wherever you are and whenever you are going to watch this video. So this is our first video for calculus under the mathematical stream. So today I just want to give you the first thing that I want to give you. I want to give you the tips that made me to master this subject, and then the second part of the lesson also, which is what the lesson is about, which is functions and graphs. So I'll just give you a few background definition of function, just few examples regarding functions, and then what to expect, and yeah, I want just slight introduction, and then the second video definitely it will come. The part one will constitute the real-time examples. So for now, people, let me just start with the tips, things that have helped me to become, one of the best student in calculus, for over 2 years. So the most important thing, people, that I would love to highlight, before I can even go down to those 3 important points, just build a good, just build what? A good habits, people. Good habits are what make a good student. Build good habits, people. And then I can never stress to over emphasize this important thing. So build good habits, people. So whatever tips that I'm going to give out, make sure, people, that you build a consistent routine around them, so that you can be able to see good results, in your marks, in your school performance. So yeah, people. So the one thing that I've learned to appreciate about mathematics is that, people, maths is not what, people, is not a spectator sport, people. That's what I've grown to realize and just appreciate, meaning, people, it's not a spectator sport, meaning you don't just sit, and don't be involved and just watch things go by, and then you think you'll be able to grasp and understand this beautiful science. You can't. You must be involved, people. You must go to class. You must participate in class. You must ask questions. You must seek help. You must do questions. You must ask questions, people. You must seek help when things are getting difficult. People. So please try by all means, people, that you participate. Make it a point. That's why, like, I always stress out to my learners, people, make it a point that you prepare before class, so that at least you have some burning questions that you can be able to ask during a tutorial or a lesson. So prepare before time, so that when you go to class, maybe to the lecturer or whoever is in charge of that of your calculus, make it a point that you ask questions, and then you can't ask questions if you don't do math, so you need to do it. So it's not a spectator sport. You must be involved, people. Go to class, ask questions, all those stuffs that makes you be involved, and then that's when you'll be able to learn. And then the number two, people, the principle number 2 that have also helped me is that work, not only to cram and pass, but work to understand, people, what the underlying principles, meaning there are some laws, there are some principles, mathematical principles, that are going to be introduced to you especially during the start of each chapter or each unit. So make it a point that you know the purpose of that particular unit. What is it? What's the purpose of us doing this unit? So the question lies there, meaning that's where you'll get the principles. That's where you'll get the juiced, the I don't know, I don't want to use my vernacular language, but people, the umongo, the principle, the laws that are underlying that particular principle. Once you understand and you are able to apply those particular principles, and then you're just done. That's why I'm able to create just maybe a 50 pages like unit. I'm able to take, and bring it down maybe to 10 pages, because I've taken out important stuff that are important, that I need to focus on. The rest, people, is just the elaboration, also the examples, all those things. So just make sure, give yourself time to understand the principles, the underlying principles, the laws, And then number 3, people, which is my last in this case, because I don't want to make this video too long. So from here we'll just go straight to the lesson. So there's the third one, people, which is not really my last one, because I wish to I wanted, and my wish was to elaborate more on these principles, because there are also principles that are underlying these 3 ones. So the last one in this case, people, is that mathematics, people, mathematics is cumulative. Sorry. Mathematics, people, is cumulative. So this means that, people, if it happens that maybe you didn't attend a particular class, if it happens that you skipped a particular maybe work for maybe a particular week of work, and then you'll find it very difficult to understand the upcoming chapters, because we build on top of something, people, on mathematics. That's why, firstly, they will start on functions, and then understand everything that has to do with functions, people. And then, it's building up, and then we'll go to derivative and so on. Meaning it's building, it's cumulative. You'll get really difficulty. You'll find it very difficult, people, if you just skip maybe a certain type of topic maybe, and then you jump on the next one. You find that there will be a prerequisite knowledge, meaning a pre-existing knowledge that we expect you to know based on the previous chapter that you've done. So make it a point that, people, you don't skip any lectures. Make it a point that you always understand, people, chapter before moving to the next. So that's why it's very important to be consistent. So these are the 3 principles that work for me, Then you build your habits around them, people. Build habits around them. The first one, math is not a spectator sport. You need to be involved, people. Number 2 is work to understand the principles, people. Make sure, work to understand the principle. Once you understand the principle, people, it's just easy. That's why I always refer people to basic, those introductory pages in the beginning of the unit or of a chapter. Make sure you understand what the chapter is trying to teach you, and what are those important points, And then mathematics is cumulative, meaning, people, we build something on top of something. We don't just build. We lay foundation after lay foundation. We come up with stage number 1, stage number 2, stage number 3 on top of the other. So these are the 3 principle. I believe that you will take a lot, and I believe you will really get to apply them and just see, people. But if you have something that works for you, good for you, people. But consistency, And then, today's lesson, people, it's about functions. It's about function. So I won't be really, be too elaborative, I won't be too elaborative in this video, but I'll be very straightforward, because what I believe whatever that I'm going to explain, it is exactly what you'll need for your exam, people. So the first thing that people, you need to understand that before we have function, a function, people, comes from what, people? Comes from a relation. So there is something that is called a relation. And so relation, people, it's simply the way you understand it. We relate something to one another. But in this case, people, since it involves I'll have to continue with this relation now. There is something that comes in my mind, which is function. So this means what we are relating, people, we are relating x and y. We are relating x as our input and then y as our output. That's what we are relating, people. Okay, when x changes, when I put 2 maybe on x, when I make x is equal to 2, what will happen to y? When I put 4, what will happen to x? When I put 4 on x, what will happen to y? So meaning we're trying to relate 2 variables or more. It can be more variables, but in this case, people, it's just limited into 2. So meaning now we are relating what? Variables now. So in this case, those variable, people, is what? It's x and y. But now, people, moving forward now, then there are different types of relation, people. There are different types of relations. But specifically, here on calculus, people, we are going to focus this one type of relation that is called a function. So that is why I just don't want to confuse you, going about the history of things. So we're studying relation, but in this case specifically, we're going to study function. So different types of function, but we are going to focus on this a relation that is called function. But now there is something that you need to understand. Remember, I said the relation in terms of mathematics, in this case specifically on our focus on the calculus, we're going to be relating two variables, which is x and y, and x is our input and then y is our output. So we want to know, when we put something, what will be the output? Meaning when I make x maybe is equal to 5, I want to know what will happen to y. So in this case, now function now is a type of relation that you're going to focus. So we need to understand the type, the definition. We need to know, what do we mean when we mean function? So what do we mean, people? A function, people, is defined differently. It is a rule, or it is other people call it machine, or it is what, people, is a mathematical relationship of two variables. So we are focusing those that have two variables, because a function can have the 3-4 functions. So these two variables, people, are what? Are input and our output. Is a rule or a machine or a mathematical relationship of two variables. So of a function, people. Of a function. So in this case now, it's a relationship. It's the way we relate these two variables. It's a rule which we use to relate these two variables. So the most important thing that you need to be careful of now. So in order for it to be a function now, it must be what? It must be a rule. That's the first thing, or a machine or a mathematical relationship where we relate two variables, which is input and output. I hope people, you are with me. But now there is something that comes into point, meaning this one, people, is what makes it a function. It is what makes that particular rule or a machine or a mathematical relationship a function. So this rule, remember, it is the rule or mathematical relationship that we use to relate these two variables, the input and output. But in this case, please check it out, people. This is the most important, that each output, each input, which is x in this case, is related to 1 and only 1 output, which is y. So please, people, please take it out. The most important thing is that, people, when we relate my input and my output, people, is that my input is related to 1 and only 1 output. So this means now I can put different input, but the only thing that I must get a unique output. So in this case, I relate what? X. I can have many x, but whatever that happens inside this machine, a machine, it can be function. Maybe let me give it in this case an example of 2x. So whatever value that I choose here to make x, I can make x maybe 2, I can make x 4. Remember, my output, it must be only 1. It must be unique. So if this is the case now, remember, I can put as many y, I can put as many x and different x's, but whatever that I get on my y, people, I must get a unique value, and then that qualifies that machine or that equation, people, to what? To a function. To a function. So it is not a function if it gives you different y. I'll try and explain it more, and things will make sense, people, as time goes by. Remember, as we try to practicalize this theory, things will start to make sense. So just be patient with yourself also. So this means now, people, this means, for example, I have a function of what? 2x, and I can put as many input here, people. I can put as many input. An input, it can be 2, an input, it can be 5, an input, it can be 10, an input, it can be maybe 15. So whatever that I must get if I put 2 on this one, whatever that I must get when I put 2 here, people, it must be unique and it must never come out again. So that will make this 2x a function. Can you see that? So in this case, people, if I put 2 here, it's going to be 2 times 4, meaning it's going to be 2 times 4. No, pardon, 2 times 2, which makes it 4. And then if I put 5 here on x, it's going to make it 2 times what? 2 times 5. And then my answer will be my 10. And then if I put x on, I make x 10, people, it's going to be 2 times 10. And then my answer is going to be 20. Then if I put 15 here, it's going to be 2 times 15. And then my answer, 15, people, pardon my writing, it's going to be 30. So what does this mean, people? It means, if you can check that each and every value, people, or output that I get, people, is unique. There is no 4 that is being repeated or 10 that is being repeated. This makes it or qualifies this 2x equation as what? As a function, because one value of x gives a unique value of y. I hope it makes sense, people. So now, people, remember, I have to also give you something that doesn't qualify as what? As a function. Something that does not qualify as a function unless certain conditions are met. We understand that, people. Remember now, we have also an example of a function that is x squared. Can you see that? So now, please be careful and observe here. Is that we can have maybe our inputs. Let me start on -4, -2, and 0, 2, and 4. And then this is our machine now, people, here. This is our machine here. That machine is my x squared. I just want to differentiate something, people. Remember, when you put now a -4 here, people, when you put -4 here, the answer that you're going to get as an output, people, it's -4 taken twice, people. This is going to be your positive what? 16. And then when you put your -2 as an input, now the output that you're going to get, people, is going to be -2 taken twice, people. It's going to be your what? Your 4. Then your 0 taken twice, people, is simply going to give you 0. And then when you say 2 taken twice, 2 taken twice here, people, when you make x as your input now, 2 taken twice, what answer do you get, people? It's going to be 2 taken twice is going to be 4. And then when 4 is taken twice, people, as an input, 4 taken twice is going to be what? It's going to be 4 taken twice, it's going to be 16. So now I want you to be observant here, people. Remember, if you are required to draw this type of a graph now, people, now your graph will be something like this, people. Will be something like this. Pardon me, it will cut here on the origin because it is 0 and 0. So it will be something like this. Okay. So now, people, when you draw this graph, you're going to have this. So now, please, people, please, because I'm trying to elaborate something here, because we also have different types of function, many to one function, one to one function, all those types of scenarios, one to many function. Can you see that? So now please be observant here, people. Please be observant here. Remember the question. The question was, people, the definition of the function was that each input is related to one and only one output. So this means this x is only related to 1, meaning this -4 is only related to 16. This -2 is only related to 4. This 0 is only related to 0. This 2 is only related to 4 also. Can you see that these are unique? These are unique and they are related to unique numbers individually, so people. So this qualifies this what as a what, people? As a function. But now it's a different type of a function now. Because people, you have unique here input, but the output is not really the same, people. Please don't take this maybe differently and just misunderstand. You have outputs which might be the same, but they have unique input. So this means it's 1, 2, many. But the above function, people, the above function of 2x, unique input gave us unique output. So this made this function 1, 2, 1 function. I just hope people this thing makes sense, but I believe, people, things we tied out as we move to the practical aspects of a function. So just be patient with yourself, people. Don't be too hard on yourself. But now, Prof Mananga, I heard, man, you put out you define the function the best way you know how. But now, what does not constitute now as a function now? What doesn't constitute now as a function now? Then remember, what did you say? We said that 1 input relate to 1 and the only one output. So if there is a situation, people, that defies this rule, then it's going to be it's going to give us a situation where that particular expression or that particular maybe equation or that particular formula or that particular machine or that particular mathematical relationship is not a function in this case. So in that case, people, is when now we have maybe y is equal to the root of x. And then remember, now there are no conditions placed on this. Then we know that this is not a function. But based on what grounds does this qualify not to be a function? So please observe now. Take this machine, people. Take this machine, take this mathematical relation, and just try and give out random values, people, and then you will see So let's try and observe now. If you check, you put your x, your y is equal to x, and then you try and solve and make x substitute of the formula, y square both sides, and then your x will be equal to y squared. If you can check, can you see that the y, people, is squared? So this means now you will have not only one output, but you are going to have different y values. Y values for each value of x. So this means for each value of x, a unique value of x, you will have different y. So meaning for a unique x value, you are going to have, for that particular maybe 2, you will have as x, you will have many y's. So this won't qualify as a function. Let me just give you an example, people, just to make things slightly better for you to understand them. Remember, my function is y is equal to root of x. So check this. For example, x is equal to 2, x is equal to 1, x is equal to 0, and then x is equal to negative maybe 2. Okay, but we know that this won't qualify on this function, because remember, a square root of a negative answer is what, people, is undefined. So this, I'll just take it out. Please be observant now, people. If you take y, x man, and substitute in this machine, people, or mathematical relation, what answer are you going to get? So please be observant, and please bear with me. I'm looking for my calculator, people. Just a few seconds. Okay. Oh, I don't need. I won't need it. But check this, people. Remember, a square root of something, people, always gives you what? 2 values. We know that it's constitute plus or minus. Can you see that? So can you see now I have different values. The one value is the one that is positive, and the other value is the one that is negative. And remember, this one, they represent my output, meaning they represent my y. So can you see that for each unique value of x, I have 2 values of y. And what is the definition? The definition is that one value or one input, each input is related to one and only one output. But in this case, we have 2. So this does not qualify as a function. So let me write it clearly so that things can make sense. So remember, this is my what? Input. We are focusing on this function. This is my input, and these are my what? Output. So can you see that if I make x 2, I get plus or minus root 2. Then if I make x, I make my x to be 1, the value that I get, it's plus or minus 1. Can you see that? Because the square root of 1 will be 1. Can you see that I get 2 values? If I make 0, 0, 0. But the most important thing that I want you to take out is that, people, the output here, people, the output, remember, the output here, people, it's what, people? It's 2 values for unique value of what? Of x. And the definition says we must only have one and only one output. So in this case 2. So this does not qualify what people is not a function. So I just don't want to make this video long, but I believe like as on my part 2 video things will tie up, because I'll be having a lot of examples that will clarify this theory, because I believe that practical aspects of doing things, people come also with their own understanding. So there's an understanding of theory, and then there is also an understanding that you're going to gain when you apply that theory. So I believe I did my best to just try and wind out and try to simplify the definition of function, because that's where things start, people. Once you missed it here, people are going to be having hard time, because under function, that's where a lot of foundation is being laid for this course. So I'll just end this video here. So thank you, people, for watching this video. Please make sure you like and subscribe and share this video with your friends, people. Sithi Makukanye, thank you very much. It's Professor Manqanga signing out.